My name is Sudipta, and this is my Physics 2212 Lab 4 Magnetic Braking with Faraday. So the purpose of this lab is to observe and collect data from a magnet falling through a tube of aluminum foil in order to apply Faraday's law. We will then create a computational model and compare those results to the experimental. So for my experimental time, I found it to be 2.7 seconds, and the theoretical time, I found it to be 2.67 seconds. So the main models and fundamental principles used in this lab, I used Biot-Savart law to calculate the magnetic field, Ohm's law, which relates voltage to current and resistance. In this case, voltage is amp, Faraday's law, and in this case, N is the number of loops, and this is found by taking the derivative of flux, magnetic flux, which is the magnetic field times the area, and then Newton's second and third laws, which relate acceleration, mass, and force to update position and velocity. And some of the assumptions for this lab, I assume the bar magnet acts as a dipole, that we can ignore Earth's magnetic field, and that there is no air resistance to be taken account for. So for this lab, I assume the system to be the bar magnet, and the surroundings to be the aluminum foil and surrounding world. I dropped the magnet north pole first through a stationary tube of aluminum foil as shown on the right here, and then I repeated this for 5 trials. Then I determined how long it took to fall by analyzing video footage. So in this case, the magnetic force opposes the gravitational force, which points downward, and the magnetic force therefore points upwards, but since the magnet's motion is downwards, the overall net force is also downwards. So for each of the trials, I found the time by analyzing video footage, and then I took the average throughout these trials. And then on the left here, these are my measured values. So for the length of the tube, I found it to be 0.33 meters, the width 0.011 meters, the inner tube radius 0.016 meters, the outer radius 0.026 meters, the mass of the tube 0.026 kilograms, the dipole moment 2.21 amp meters to the second squared, and the average time 2.7 seconds. So why can't we use a Ferris tube? A Ferris tube would create its own magnetic field and interfere with the falling magnet. Then what happens to this magnet, and how does this compare to it falling in free space? The magnet would fall faster in free space than within the tube because the tube creates an upward magnetic force from the induced current. So this is my code that I inputted through closed script. The length of the tube, the width, and the inner radius, and the total radius were all values from before that I just plugged in. Then I calculated the magnetic field, which is just Biot-Savart law. And then I found the time derivative of the flux through each ring due to the falling magnet. And then on this side, I calculated the gravitational force and the magnetic force. And then I found the net force, which is the magnetic plus gravitational. And I applied Newton's second law to update the magnet's velocity and position. And then I plotted a graph of velocity versus time for the magnet as it drops. So on the right, this is my graph with velocity on the y-axis and time on the x-axis. So the time taken to fall through the tube, for the experimental, I got 2.7 seconds, as mentioned before. And then for the computational, I got 2.67 seconds. So the computational model time was slightly lower than the experimental time. And some sources of error include air resistance, timing error from when determining when the magnet enters and exits the tube, and an inaccurate dipole moment. So what if the resistivity of the conductor were reduced as close as possible to 0? How would the dynamics of the falling magnet change? If the resistivity of the conductor were reduced as close as possible to 0, the induced current would have a larger magnitude, which creates a stronger magnetic field, slowing down the magnet at a higher rate. So if there were holes or slots cut into the tube, how would this affect the ring currents in your model? The holes would disrupt the current, which results in a weaker magnetic force opposing the magnet, causing it to fall faster. Thank you.